but it is in the videos, so please check out the videos. I know they got up late last night. I apologize for that. Look at all the people phoning in. Who else we got here online?
I mean, I can agree with that, but still.
So we've got two different paths, or it's this really the same contour. It's the same curve, but we're taking it from two different directions. And maybe I'll get you started on R1, and then like I'll give you a little bit of time to try R2. So if we do A, I'll call R1 A. We need to find R prime of T. So R prime of 1, or R1 of T prime, is 1, 6T, and 18T squared. So the magnitude of that we've got, not a vector, 1 plus 6T squared plus, ooh, this got ugly quick. Maybe there's not a lot we can do with it, but we'll check it out. I got 1 plus 36T squared. 18T to the 18 squared. I wonder if that factors. 324 T to the 4th.
It does not.
No, because if it factored, it would be like 18 times 1, 18 times 1. Oh, shit, is it? Is this 18T squared plus 1 squared? It is. Look at that. So this just ends up being 18T squared plus 1. If we multiply, factor, FOIL that out, multiply it out, I get the 18T squared squared. I get 18T squared plus 18T squared, which is 36T squared. And I get the 1. So it is 18T squared plus 1, that quantity squared. And since we're taking the square root, and T squared's already, T squared's positive, 1's positive, I don't need the absolute value signs. That's just what the magnitude of the derivative is. So how do we go about doing this problem? We rewrite our integral in terms of T, following this pattern. So T is going to go from 0 to 1, like we listed there. And I want to replace X with T and Y with 3T squared. So I've got T squared and then 3T squared. That's my X squared Y. And then my DS is going to become 18T squared plus 1 dt. That's the DS. All right, what does that turn into? I got T squared, squared, squared. There's T to the 6th. 18 times 3 is 54. So I got 54 T to the 6th plus 3t to the fourth. Am I doing that right? That's about right. And we integrate this bad boy and we get 54 over 7 t to the seventh plus 3/5 t to the fifth. Evaluated from 0 to 1. 54 over 7 plus 3/5. 5 over 5, 7 over 7. 5 times 54 is 270 plus 21 over 35. I'm getting 291 over 35. $250 and 20, yeah, 270 and then 20, yeah. All right. So that was doing it with R1. Let's check out R2. Let me pause and let you guys digest that shit. And I'll bring that camera back down and show you guys R2 again. We'll do it on the next sheet. James, I really appreciate your father. I was feeling a little guilty about the difficulty of the regular test. And I said, Mr. Blakely, this is the pickle I got myself in. And he said, do not send them with the take-home test if you're trying to, or take-home questions, if you're trying to make sure that they're doing shit in class. You're just going back on everything you're trying to do. And I said, you know what? You're right. I started to panic in my guilt and was going to do something I didn't want to do. And your father saved my ass. Still teaching. So you can blame James and his family if you wanted to see some take-home problems. All right, so we're going to do the same problem, but we're going to use R2. Okay, so I'm copying that information over to another sheet real quick.
Can you move your the whiteboard so we can see the bottom still?
What?
Can you move the whiteboard so we can see the bottom still? The last word.
Oh, it's kind of hard. I guess I can shrink it down. You just walked in. I'm trying to do the next part, buddy. So that says 291 over 35. That's the part you're missing.
Yeah.
Walk in 10 minutes late. Probably visit him with Quinn, huh?
So 10 minutes late. I was actually very on time.
Were you?
Yeah.
I thought someone just walked in. I thought it was you. You're wrong.
Not even 10 minutes after class yet. Barely April 19.
Okay, nine minutes.
But I didn't just walk.
Okay.
Damn.
You're not here. 291 over 35. Unless you learn to do some math in your head.
Fuck that. 35.
Right,
Maybe
if I
that's
get
why-
you down to this point, you should be able to finish it out. I mean, come on. All right, let's look at the other path. Again, 0 to t to 1. So I hope our R prime, I don't need the norm part there yet. Let's just find R prime. We got -1. We've got. Why does this look so much different?
What?
I think I just made this shit up and we're not going to get the same value. But fuck it, I'm going to try. Let's see what we get. This is a lot easier, which makes me think we're not getting the same value. I made up R2. R1 was from,
Copy wrong or I copy wrong?
Oh, yeah, I think it might have been 3 minus, it might have just been 3 minus T that.
You check the first word.
Check the first, double check the first word.
No, I have to.
so
Oh,
let me make sure I did that right. I had,
All right, never mind, Eric.
that's what the problem I was going with for.
Oh, that's good.
A bigger deal for Eric to be wrong than Mr. Jones.
Oh, you think
Oh, I know the problem. This is following a different path. The last path was not a straight line. This is a straight line. I don't know that we're gonna get the same answer, but shit. Oh well, fuck it. We're doing it.
I'm pretty sure he needs people like that.
You know what? No, I'd rather not. Let's go back. Let's go back to the other. I would rather do a different lesson. Let's do we're back to R1 of T. And we got T, 3T squared, 6T cubed. And now we're not going to do DS. We're going to just do DX. So maybe we don't want to find the line integral along the whole line. We just want to do how does it change with respect to X.
He's changing the
So
problem.
the way when we do something like this, we don't have the full DS. The equation changes up a little bit. We're going to do f of x, y, z dx along the curve turns to t equals a to b, f of x of t, y of t, z of t. And instead of having dr dt, we just have x prime of t dt. If we were doing the same thing with dy, oh, I wanted different colors. If we were doing dy, this will change to y prime of t. That's the only shift. And if we were doing dz, the only shift is z prime of t.
It might be easier to look at it like this. Because he's removing the dx by having this.
Because
you have
if we had dr dt, but we're only looking at something that's happening. Remember, dr dt, or the magnitude of this, sorry, is dx dt squared plus, you know what, I'm gonna do this. But if we're only looking in the direction of x, then this is 0 and this is 0. So this just ends up being x of t. So it's still the same dr dt, but stuff has changed. All right. That was just explaining where it came from. It's in the video. If you want more of that, this is for problem solving. Let's give it a try. We already know what the derivative of the magnitude, well, we're doing that. We want x prime of t. X prime of t is 1. And so this curve changes from 0 to 1 for t. We're doing the t squared for x is x squared, and then we've got y is 3t squared. And we've got 1 dt. That's my x prime of t dt. And this got really easy. This is 3t to the 4th. dt. And we get 3/5 t to the 5th. From 0 to 1 is just 3/5.
So here's that terms of DT. You see the next slide. The expertise kind of shift that to DT. But I don't remember exactly how that does it. But if I'm going to be honest, I think they were thinking about this. Yeah, I was thinking about that. That's actually better. Yeah.
While you're looking at that, why don't you guys try doing the curve along dy
He's just
while I get another problem ready.
It's trying, it's getting in terms of two, that's kind of key. It's taking it from the R vector like that. So it's wide. So last we did it with the whole vector. What? Last time we did it with the whole vector. This inside of it. So. It's the doing. He said he was going to do it both ways. Oh yeah. I read the book. Yeah. The way, yeah. She did it came out last night, so nobody probably got too much. Yeah, so I know a lot of people are lost. Watch the video. Hey, at least you'll be a little less lost. Are we going to get back here? Yeah. Okay.
I actually was reading the book, and that's like how I before the videos were released.
What are you talking about?
Since the videos weren't released, I decided to read the book instead. Since that,
Okay.
yeah.
For you.
All right, we're gonna do this curve. This looks like a fun problem. And let's show the curve. Draw a picture. You guys ready? Oh. So what did you guys get on this one? We should have dy or y prime of t is 6t, right? So you should have 0 to 1 t squared times 3t squared times 6t dt. And we got an 18 there from the 3 and the 6. And it looked like I got t to the 5th dt. So 18 over 6 is 3. Evaluated from 0 to 1, and we get 3.
So looking at it, essentially, okay. So I think I understand how he replaced the why he replaced the x prime of t with dt's and how you did that. Essentially, you know that dx dt is a value that you can find because it's part of dr. That's where the one term came from, because in the x part is just t. That comes to 1. And then you added dt and dx to equal this, because usually dt would cancel this. So dx. It's a replacement method. But why did we replace it? Because we're trying to get in terms of dt so we can solve it. But earlier we just did it with the magnitude of the whole vector. That's what I'm trying to.
Right,
It's
but earlier
still
we were doing s along the curve. Now we're doing just
Yeah.
with respect to x.
Mhm.
That's the difference, or respect to y. On the previous one, we were doing ds. So we were following the arc line, or following the arc. Does that make sense?
Then. Yeah, and I run, yeah.
Is everyone good? This has applications to physics for all you physics lovers. Let me point it out.
No.
Work in a vector force field. Is F dotted with the tangential vector ds, which ends up giving us along the curve. If you're doing some work in a vector field, this gives you F dotted with dr, and you've got F of r of t dotted effectively with dx dt, dy dt, dz dt. That looks like shit. And if f is a function, if f has individual components, maybe f, g, and h, then you're going to see that you're going to get, with respect to t, we've got f times x prime of t plus y time, or g times y prime of t. So this has applications in physics. H times z prime of t, and then we've got all that's with the dt. So there's a reason for learning these line integrals with respect to one variable, because they play a role in doing stuff in vector fields. And that's where a lot of physics meets reality. A lot of the stuff that we've learned in how to master with in life with using physics and mathematics and engineering comes from applying all this shit together. So there's a motivation for learning this. For those of you that like physics, that's just one example, work in a force field, whether it's gravitational field or you're trying to move something through the force field.
I'd like to make a correction. It's not those who like physics. It's those who are taking physics and need to know this to pass. Am I right, Lawrence?
No, physics, they'll teach you the same thing in physics. Hopefully Quinn's teaching like, well, Quinn probably taught you this shit like 8 weeks ago for those of you in that section. Because Quinn likes to, Quinn, I can't believe Quinn was putting me on blast about linear transformations. And then he's expecting you guys to know like triple integrals and shit when he knows you haven't learned it yet. That was funny to me. This is Lawrence passing on information from Quinn. When Lawrence went to math help, he betrayed me. All right, so that's kind of a motivation for doing it. Let's look at a problem where we have this curve right here. It's a triangle. We're following the triangle, and let's do it two ways. And this is the function we're evaluating. Let's go step one. Let's go, I don't know, counterclockwise. And B, maybe clockwise. Let's try it both ways. So we can break this. We've got 3 lines. This is actually like a C1, a C2, and a C3. So if I start at the origin and I go this way clockwise or counterclockwise, that's C1, that's C2, and that's C3. And I can break this up into doing 3 intervals.
Right.
I can do C1 plus C2 plus C3.
Correction. So that's how it's.
So how do we go about getting that? So first off, we got to make a vector. We got to get an R of t. So let's look at C1. C1 is going from 0, 0 to 2, 0. So let's pull out some shit that we learned a long time ago in this class. R of t equals 1 minus t times R0 plus t times R1. So I can treat this as R0 and this is R1. And R of t is, I've got 1 minus t times the 0 vector plus t times 2, 0. So I'll call that R1 of t because it's our first contour. 1 minus t times 0 is 0 plus t times 2 is 2t. And the y component is 0 on both of those. So that's R1. Let's look at curve 2. I'm going to put this over here so I don't lose it. It's easier to find if I store it over there. Again, we're doing 1 minus t. So 1 minus t. We're starting on curve 2. We're starting at 2, 0. And we're ending at 1, 1. So I've got 2 times 1 minus t plus t for the x component. And 1 minus t times 0 plus t for the y component. If I clean that up, I get 2 minus 2t plus t is 2 minus t and t. C3. We're going from 1, 1 to the origin. So 1 minus t times 1, 1 plus t times 0, 0. And since the last component is gone and the first one is just 1, 1, this is kind of easy to see that you're going to end up with 1 minus t, 1 minus t. Put a little box around those because we're going to use those. All right, so let's look at our curves. So let me make sure I have that up there. I'll bring this down and remind us right here. The curve is y dx, or the function is y dx minus x dy. That's what we're looking at here. So let's do curve 1. In each of these, the t is 0 to 1. That's the beauty of setting it up like this. This works for paths that are straight lines. We can do this R of t thing. So curve 1, we're going to do from 0 to 1. Y is 0. So the 0, we got 0 dx. That's good, just going away right away. Don't even matter what dx is. Minus 0 to 1 of x dy. 2t times, look at that, 0. So there's nothing along curve 1.
Oh, gosh.
If we look along curve 2, we've got 0 to 1. I need to do y. Y for R2 is t.
Nice.
And dx is going to be -1 dt. And then I've got minus the curve along 0 to 1 for x dy. I've got 2 minus t. And dy is just 1 here, so 1 dt. I could probably add this together. 0 to 1, I've got -t minus 2 plus t. Is that just -2 dt? -t minus a -t is plus t, so the t's cancel. And I got -2, yeah, that's all that ends up being. So we got -2t from 0 to 1. This is -2. And then we go along curve 3. So I need y 0 to 1 of y dx. Y is 1 minus t. Dx is -1 dt. Plus 0 to 1. Not plus, minus. X is again 1 minus t. This looks like the same thing.
5 looks like 0.
So I've got literally, if I look at this, call this smiley face. I've got smiley face here. Smiley face minus smiley face is 0. I don't even need to do the integration. If I look at the bigger picture.
Smiley face minus smiley face is equal to O face, then O face.
If you had a smiley face and you lose your smiley face, now you just have your, oh, I'm so sad face. So the total integral is just -2. I got 0, -2, and 0. If I come back up here, 0 plus -2 plus 0 is just -2. So that's the answer of doing it that direction.
So, Mr. Jones, I don't know. Maybe I just can't remember. But the where you got the R vector of t's for your c's, the 1 minus t plus t. I haven't. Isn't it you when you're finding a vector between points? Isn't it usually one point as a base and then the second point multiplied by t?
Which part do you have in the approach?
No.
Okay.
If you think this isn't going to work, go through and plug in t equals 0 and t equals 1. If I plug in for R1, if I plug in t equals 0, I get 0, 0, which was my starting point. And if I plug in t equals 1, I get 2, 0, which was my end point.
Okay.
If I do the same thing for this one, I plug in 0, I get 2, 0 to start with. And if I plug in t equals 1, I got 2 minus 1 is 1, and then 1, 1, 1 was my terminal point.
Okay.
Same
So,
thing if
and
you do
then-
this one.
Yeah. Then where was your reasoning in using and how, or maybe not the reason, where did you get the 1 minus t r naught plus t r1?
Go back to chapter 11 or 12.
Okay, so it was back.
This is old material. I don't want to rederive it when there's other shit to do.
No.
We did this before. You just have forgotten.
For just been a while, yeah.
It's been a while.
Okay.
That's why I said this is a reminder. I knew people were going to have forgotten. And this is only on straight lines. This only works for straight lines.
Yeah.
And conveniently, these are straight lines. Let's do this the other way. So I'll set up the, I'm gonna redraw this on, we're gonna go clockwise now. So let's do, I'm writing the equation on another page. And 201100. Is everyone done with that tab for now? I think I'm gonna pointing out to Brandon real quick as a reminder where we get that other thing. 0.1, 0.2. That's R0. This vector is R1 minus R0.
Okay. Yeah, makes sense.
So if we're going from 1 to 2, it's R0 plus T times that. Because we're just looking at this component.
Oh, and I'm already seeing it.
And we've got we've got R0 minus TR0 plus TR1. So 1 minus T times R0 plus T times R1.
Okay, yeah. Yeah, that makes more sense.
It's been a while. That's your review.
Don't worry. Again, how many times you told me that's my answer? No problem before. Don't worry.
I'd rather have you trusting my judgment in the equation and just take a minute to show it real quick. We did it before though. So now we're going to go clockwise. So let's go this direction. So I'll start at the origin. I'll call this one C1, this one C2, this one C3. I wrote the arrow going the wrong way there. So for curve 1, we're starting off from going from 0 to 1. Again, R is 1 minus T times R naught plus T times R1. So along curve 1, R equals 1 minus T times 0, 0 plus T times 1, 1. And we'll call that R1. And R1 is just TT. If we do C2, R2 is 1 minus T. We're starting at 1, 1. And we're ending at 2, 0. So I've got 1 minus T times 1 is just 1 minus T plus 2T for my X component. My Y component is 1 minus T plus 0. So R2 is 1 minus T plus 2T is 1 plus T. And the Y component is 1 minus T. That's interesting. And finally, from 2, 0 to the origin, I've got R3 equals 1 minus T times 2, 0 plus T times 0, 0. And it looks like the only component we have for R3 is 1 minus T times 2. So 2 minus 2T comma 0. I'll give you guys a second to pause and catch up with that. Make sure we're all on the same page. All right, so we are breaking this integral up into 3 things. We're going to do C1 y dx minus x dy plus C2 y dx minus x dy plus C3 y dx minus x dy. So I'll just do them 1 at a time. It takes up too much space to try to do it all at once. Along curve 1, we're going from 0 to 1. Y is t and dx is 1. So 1 dt. And then I'm going to do minus x dy. X is also t, and dy is 1 dt as well. This is the smiley face minus smiley face again. Those are identical, and so we're going to get 0 without integrating. I mean, if you need to integrate, you don't spot it. When you integrate, you should still get 0. It helps if I put the limits of integration on there. So that was curve 1. If we take a look at curve 2. All right, so we're going from 0 to 1. I need y, which is 1 minus t. Dx is 1, so 1 dt. And then we're subtracting x dy. X is 1 plus t. And dy is -1, so -1 dt. There's a lot to unpack here. This is probably easier than one integral. I got 1 minus t minus -1, 1 plus t dt. So this is a plus. It goes to plus. I got minus t plus t. The t's go away. I got 1 plus 1 is 2. 2 dt. So I get 2t evaluated from 0 to 1, and I just get 2. So far, this is part 1's answer. This is part 2's answer. And if we look at curve 3, curve 3 is 2 minus 2t to 0. So if I want y 0 to 1, y is 0, so 0 dx, doesn't matter what dx is, minus 0 to 1. We need x dy, x is 2 minus 2t, but dy is 0 dt. This is also 0. So the integrating along C1 plus C2 plus C3 gave me 0 plus 2 plus 0 was 2 in the clockwise direction. And if you look back, counterclockwise was -2.
So is this answer, is it representing circulation? Thinking? Or my
It is going in. It is going in a circular, or back to its starting point.
Mhm.
We'll cover circulation later. I don't want to jump into that now with it being 3 minutes left.
Yeah.
Plus, because we look at it in with conservative vector fields and stuff like that as well. That's coming
Yes.
up. The takeaway from this is you will notice if you check out component wise by component wise, if C1, let's say counterclockwise was going forward, is going forward. So that's our curve. That makes clockwise going backwards is effectively going -c. So for doing the backwards curve for f of any of them, dx, dy, or dz is the same thing. Let me move this up. Let me do it one at a time. I think I'm rushing that. So if we go clockwise, so the negative curve, f of x, y, z, dx is the same thing as doing the forward curve, but the negative sign.
Yeah.
This is true for both dx's, dy's, and dz's on all of them. And this is, oh shit, I put a slash and that looks like a derivative, dy and dz. This is different than doing ds. When you
Have a great
do
weekend, guys.
what?
Sorry. Go
Have
ahead.
a good weekend. When you do ds, orientation didn't matter. As you'll see when, did we do that on the first one? We didn't do it both ways because I didn't have a good backwards path. So orientation matters on the line integrals with the partial. We're not doing the full ds, but just picking one variable to integrate over. But if you're doing over the full line integral, orientation doesn't matter. Going forward or backward on path, we'll do that again. We're just covering 15.2 more on Monday.
Okay.
Have a good day. Have a good weekend. It's Veterans Day tomorrow. There is no Friday night lab. There's no Mesa. School's not open
Sad.
tomorrow.
Big sad.
Big
So
I
I look forward to Friday Night Lab every week.
know you
And now
do. It's kind of sad, but
Well, the whole school gonna close, or maybe two
yeah, the
of
school's
centers?
closed for Veterans Day.
Fuck.
have a nice rest of your day.
You too.
I gotta catch up on this because
Alright.
I read the book and I was like so lost because it's like
Did
I don't
this
know.
help?
I feel like that helped a lot.
Okay,
For the
good.
process at least, I'm gonna have to conceptually that also helped a little bit with.
We're gonna hit it again on Monday too, Jericho.
All right.
Okay.